Hi everyone, welcome to my Core 3 past paper video. Now on this video I'm going to be doing the whole Core 3 2011 June paper. I've already got 2 videos of question 3 and 8 of this paper on YouTube, so when I make this I'm going to skip those out and insert them in when I edit the video, so that's why the screen might change a little bit. Anyway, with that said, let's get down to business and have a go at the paper. Question 1. So we've got to do some integration. We're trying to integrate 6e to the 2x plus 1 with respect to x. Okay, and we can think of this 6, because it's just a multiplier, as here if we want. So whatever our answer is to the first bit, we can multiply it by 6. Okay, now when we integrate e, we get e, but that's if it's e to the power of something. Okay, so we would hope that we get that. But what we're going to do is we're going to make a guess and differentiate our guess. Okay, this is called integration by inspection or recognition. When we do differentiate this, we're going to get, because of the chain rule, 2e to the 2x plus 1. That means that if we want just 1e to the 2x plus 1, we need a half there. So we divide it back. That means that we know that if we want to integrate e to 2x, we get this answer above. Okay? And don't forget the 6. 6 times a half is 3. So you get 3e to 2x plus 1. Do not forget plus c. Part 2. So again, I'll take the 10 outside. Integral of 2x plus 1 to the minus 1. Now from Core 1 you know a different way to write that. 1 over 2x plus 1 dx. Now the integral of 1 over something is ln of it. Okay? So we're going to guess, we need modulo sign, ln 2x plus 1. When we differentiate, that's our guess, ln of 2x plus 1, because of the chain rule, we have to multiply by 2, get 2 ln 2x plus 1. So that means that if we actually didn't want this 2, we would need an extra half in the front here. So we now know how to integrate ln of 2x plus 1. And do not forget the 10. The 10 is being divided by 2, so we get 5 ln 2x plus 1 plus c. Okay? Question 2, transformation question. So transformation was in Core 2, but in Core 3 it makes it quite a bit harder and the order matters, so you have to be quite careful. So our original function, f of x, is ln x. The first thing that we do is a reflection in the x-axis. So the way I think about that is your x-axis is your mirror line. So actually what's being affected is vertically. Okay, so you're doing it to y. So to reflect in the x-axis, you're going to have minus f of x, aka minus ln x. Is that one done? Next one, a stretch with a scale factor of 3 parallel to a y-axis. So it's this way again. So you're going to multiply f of x by 3, get minus 3 ln x, followed by a translation in the positive y direction by ln 4. Again, we're doing it to y. Okay, so we do it outside f of x plus ln 4. So in terms of our equation, minus 3 ln of x plus ln 4. Let's read the rest of the question. Find the equation in the form curve, giving your answer in the form y equals ln of something. That does not mean that you leave an f of x. That's just something to do with x in your answer. It's giving you a clue of how to write it. Okay? So y equals minus 3 ln x plus ln 4. It's now testing your log laws. You can bring the power up. Okay? Minus 3 up as a power. So you're going to get ln x to minus 3. plus ln of 4. Okay, remember x to minus 3 can just be written as, need a smaller eraser there really, 1 over x cubed. Okay, and we're adding, so we times inside the log, so it's 4 over x cubed, or 4 x to minus 3. That's question 2 done. Moving on to question 3, one that I'd already done. So, for question A says 7 sine 2 alpha equals 3 sine alpha, and alpha is between 0 and 90 degrees. Our challenge, find the exact value, very important, of cos alpha. So we're basically trying to rearrange this expression to get cos alpha equals. Now, as you can see, there's no cos alphas to be seen at the minute. So what we need to do is use our double angle formula. I hope you're familiar with the double angle formula, and if not, you can look it up in your formula book, and you can put A and B as the same angle, alpha or theta or whatever you'd like. What we're going to do now is we're going to change sine of 2 alpha to 2 sine alpha cos alpha. That is your double angle formula. Obviously 7 times 2 is 14, so we can write this as 14. And now we can think about how we can rearrange the equation. Remember I told you the limits are important. This is where. To 1, sometimes it goes down to minus 1. Obviously, if sine theta equaled 0, cos theta wouldn't have an expression because we'd get 0 here, 0 here. So what we need to do is apply the range, which says the only part of a graph that we care about is this part, not including where it equals 0. That allows us to divide by sine alpha and get the expression 14 cos alpha equals 3, and hence divide by 14 to get the exact value of cos alpha as 13 over 4. That's part A then. Part B is a little bit more tricky. The equation that we've got again has boundaries for beta, the angle, and this time we want to find the exact value of sec beta. Now I say a little trick to remember sec, cosec and cot, and that is look at the third letter. The third letter of sec is C, so that means it's 1 over cos beta. So that's what we're after. What we want to do now is use our double angle formula again, this time for cos 2 beta. So we're going to change cos 2 beta to cos squared beta minus sine squared beta. Again, you can get this from the formulas in your formula book under the trigonometry section. Plus 19 cos beta plus 13 equals 0. Now we want to simplify. And as you can see, what we want to do definitely is not write 2 when there should be a 3. So let's times out. We get 3 cos squared beta minus 3 sine squared beta plus 19 cos beta plus 13 is 0. We want to simplify this. Now we only want cos in our expression because we're aiming for 1 over cos as our answer. So we need to use another trig identity, that sine squared theta plus cos squared theta is 1, to transform this to 1 minus cos squared beta. When we put all this together, we are going to get 3 minus 3, sorry, plus cos 3 cos squared beta, which gives us in total 6 cos squared beta plus 19 cos beta Now, I hope you can see that this is a disguised quadratic where cos beta equals whatever letter you desire, let's say y. So we've got 6y plus 19y plus 10 is 0. There are a lot of different ways to factorize this quadratic. I like a way that I'm going to show you in a different video, where you do 6 times 10 is 60, and we're looking for numbers that multiply to make 60 and add to make 19. Now the difference with my method is, don't panic, I put 6y on both brackets. I know that's not right, because obviously when we times that out, we get 36y squared instead of 6y squared. So I'm going to rectify that by putting a 1 over 6. Now our numbers that we're going to find just go here and here. And multiply to 60, add to 19. I reckon that 4 and 15 are going to do the trick. Now I have to complete my method by dividing by 6 through the brackets. We can divide this bracket by 2 and this bracket by 3, which gets rid of 6. That means that y equals minus 2 over 3, or y equals minus 5 over 2. Let's think about what y was. Y was cos beta. So cos beta equals minus 2 over 3, or cos beta equals minus 5 over 2. Alarm bells should be going off. Cos is a function that goes between 1 and minus 1. This is not valid. This one is what we're interested in, but the question asked for the exact value of sec beta, which is 1 over cos beta, which is 1 over minus 2 over 3, which is just the reciprocal, minus 3 over 2. Okay, question 4. Show by means of a suitable sketch of graphs that the equation x minus 2 to the power of 4 equals x plus 16. You can think this, the equal sign, separating two different equations. The equations y equals x minus 2 to the power of 4 and the equation y equals x plus 16. Now when they're equal, that is where the graphs intersect. Let's do a little sketch for part I. Okay, so there's our axis. This is a basic power of 4 graph. So it's a quartic and its root is at 2. It's a repeated root. If you, let's not go into too much detail about that. It's like a quadratic graph for quartic, but it's flatter at the bottom. Okay. We might want to figure this value out quickly. You don't have to, but it's very easy to do because it's where x is 0. So it's 2 to the power of 4, which is 2 times 2 times 2 times 2, which is 16. That's 16, that's 2. Next one, y equals x plus 16. Well, that's handy. Y equals mx plus c. It's got a gradient of 1. It crosses at 16. Okay, so it's crossing at the same point here. And it looks something like that. And you would just show your examiner, oh look, it crosses twice, 2 roots. Okay, roots are another word for solutions of the equation. State the value of the smaller root. Well, what we just talked about, here's the smaller root, and it's at x equals 0, isn't it? Part 3. Use an iterative formula. It tells you which one to use. To get your next answer, you do 2 plus the 4th root, x to the last guess plus 16 with suitable starting value. So it's keeping your options open here. If we're trying to find this root, suitable starting value could be anywhere around here really. Okay, so let's think about our values of x. why don't we just randomly start at, I don't know, 3 or 4. Let's go for 3. Okay, so our first guess is going to be 3. I will tell you how to put this into your calculator now. Okay, what you need to do is you need to type in on your calculator buttons 3 and then equals. Just to trick your calculator to save a number 3. Okay, so 3 equals. 3 is saved in your answer button now. Now type in 2 plus 4th root of ants plus 16. So I'll type that in mine now as well. 4th root, you need to use the shift button. Ants, which is your last answer, plus 16. Now if you keep tapping this, it's going to put your old answer into your new equation to get your next answer, and that cycle is going to keep on repeating. Now we've already got our answer saved as 3 for the first one. So for x1, the next answer, we press equals. We get 4.08779,763. Be as accurate as you can, but at least to 4 decimal places, because our final answer is 3. Okay, press equals again. That puts this now into there. So hopefully you can see how it's working. 4.117059,583. Press equals again. We need to do it until it stops changing to 3 decimal places. Okay, and then we've got our answer. 783, that'll do. Press equals again. 4.11785 again. Yeah, and it's not changing to 3 decimal places. You can always check yourself, make yourself sure by continually pressing equals. We can see that these are rounding to 4.118. Okay, 4.118. That's your answer. Right, that's question 4 done. 3 decimal places. Moving on to question 5. So the equation of a curve is y equals x squared. I've got a feeling I know what we're going to have to do, so let me do this in different colours. You'll see why in a second. Yeah, because we're differentiating. Okay, d2y by dx squared at the point of the curve for which x is 2. Don't let me forget that. Okay, so why have I done it in different colours? Because it's a product of 2 things. It's x squared multiplied by ln of x, 4x minus 3. And that means we're going to use the product rule. Now, I use the product rule in words. You guys might have learned it as a formula. I'm not sure, but I'm going to do it how I do it to show you that. So what I do is I do, in words, differential of the first times by the second plus the first. You can see why I'm color coding it now, times the differential of the second. That's going to need a bit of extra work. You might have to do a sideline and think, how am I going to differentiate ln of 4x minus 3? I know that ln of something goes to 1 over it. Okay, but because it's not just ln of x, it's 4x, we have to multiply by 4. Really need to make my eraser a little bit smaller there. Oops, mistake. Okay, that just needs to be a 4. So we multiply by the differential of what was inside the function there. Okay, so that's going to be multiplied by this, so it's going to be 4x minus 3. First bit done, we have to differentiate again. d2y by dx squared. Okay, we can differentiate one thing at a time. So we'll do the answer to this one in green separate. Okay, so we're going to use the chain rule, the product rule, sorry, again. This first part of the differential to differentiate again. Differential the first times the second plus the first times the differential of a second. Well, it's handy that we already know what the differential of ln 4x minus 3 is. So we're just multiplying by this again. So times it by 4, we get 8, 4x minus 3. And like I promised, I'll do this in green. Now, this one in green, we can either think of as the product rule again or the quotient rule. I'm going to just show you how to think of it as the product rule. So this, we need another sideline, I reckon, for this working out, is going to be 4x squared times by 4x minus 3 to the minus 1. So I've just cheated and made a possible quotient rule question into the product rule. Differential of the first times the second. Now we can put it underneath because it's a negative power, plus the first times the differential of the second. Now be careful here because we're going to be applying the chain rule. So multiply by the power, so you're going to be multiplying by minus 1, and then take 1 away from your power to get 4x minus 3 squared, because it's minus 2. Now, because of the 4x here, we must multiply by another 4 to get minus 16x squared. Okay, so let's put all that together. So it's 4 terms in our answer for d2y by dx squared. I'll just move this across. This one is harder to move because we did it a bit separately. Okay, so we want to now evaluate this because the question said at x equals 2. So at x equals 2, we want to find out the value. Okay, so we're going to be substituting x into this whole expression. The first term, we're going to get 5 in the bracket, 4 times 2 minus 3, 2 ln 5. The second term, we're going to get 8 times 2, 16 over 5. The next one is the same. We're going to get 16 over 5. The next one, we're going to get minus, and it's going to be 4 squared. 2 squared is 4, sorry, answer my own question. Times by 16 is 64. And below we're going to have 5 squared, 25. Right, so let's get to simplifying this. 16 over 5, add 16 over 5. Well, we've got 2 lots of them, so it's just going to be 32 over 5. Now we want to combine these 2 fractions that we've got. So ideally we would want them both over 25. And 32 times by 5 is 160. So we're going to be doing 160 minus 64, which gives us 96 over 25 plus 2 ln 5 as our final answer in exact form. If you use your calculator, get decimal, you do not get all the marks, so don't do it. Question 6. The diagram shows a curve with the equation y equals square root of 3x minus 5. So we can label this curve with that equation. I'm just going to use the power laws to say that when you're square rooting, it's the same as power of a half. The tangent to the curve at the point P, which you can see is this straight line, passes through the origin, which you can also see from the diagram. The shaded region is bounded by the curve, the x-axis and line OP. We can see that from the diagram. Show that the x-coordinate of P is 10 over 3. So here's our point P. Here's the x-coordinate. This is what we want to try and figure out. Okay, so we're going to call it x for the x-coordinate of P. Hence find the exact area of the shaded region. So our eventual aim is to do something with integration to find that area. But first of all, we've got to show that to find this x value. Okay, because we were talking about tangent line, Tangent is to do with the gradient at a point. Okay, so we're at the point P, and we want the gradient from this curve, y equals square root of 3x minus 5. So when we're talking about gradient, we want to differentiate. So we're going to get, because it's something to the power of a half times that thing to minus a half. If your thing is not just, say, x on its own, what you need to do is you need to use the chain rule, and you need to times by the differential of this thing. So differential of 3x minus 5 is 3. So that's it differentiated. So we know what the gradient is at this point, and if we're just at the point x, we keep that x as x. So when we think about the equation of this red line, this tangent line, we want it in the form y equals mx plus c. So m is your gradient, and we've just said at this point x, the gradient is this, with x left as x. So it's 3 over 2, 3x minus 5 to minus a half. Okay, remember that is just your gradient. So we still need to times that by x. Now the plus c is where we cross y-axis. Okay, and it just so happens that it's told us we're going through the origin, so our c is 0, so we don't need to put it in. This is the equation of the straight line. This is the equation of the curve. When we want to solve them equal to each other, we will find the intersect. So let's set these two equations equal. And because of the power of a half, we're going to write a square root so we can see what's going on. Minus 5. Okay, and the x can go at the top. Equals square root 3x minus 5. What we're going to do now is we're going to multiply up by this square root, all this square root stuff. The reason is that when you've got the square root of a number times by the square root of a number, you get that number. By the definition of square roots, what times us by itself to give something. Okay, so we get 3x over 2 equals now 3x minus 5. We could times it by 2 at this point, and we could get 3x equals 6x minus 10. Okay, rearrange that to get that 3x equals 10, i.e. x equals 10 over 3, which we required. Okay, so we found this x value is 10 over 3, and it's, you know you're right because it's a show that question, but quite a tricky one. Now we have to find the exact area of this shaded region. You can think of that shaded region as a triangle, big triangle. I'll draw a triangle on for you here. This triangle, take away this curved shape. Okay, and this curved shape we're going to have to integrate to get. The triangle we can use very basic maths, okay? Doesn't look very curvy, so let's just make it clear. So the triangle, it's just going to be, we need the height of a triangle, don't we? Okay, because we need a half base times height. So let's just erase this out for now. Okay, we've used that working. So we want the height of a triangle, and all we're going to do is we're going to think, well, okay, doesn't matter which equation you use, the point P is on this line, y equals square root of 3x minus 5, and if we know that x is 10 over 3, y is going to be the square root of 10 over 3 times 3 is 10, minus 5, root 5. So the value of y there is root 5. So it's going to be a half times 10 over 3, which is 10 over 6, times by root 5. So that is the value of the area of the triangle. Now we want this grey area, so what we're going to have to do is we're going to have to find the limits that we want to integrate between. We want to integrate between this value and 10 over 3. So to get this value, we're on the curve, and we want to be on the x-axis, which is y equals 0. So we're trying to solve the equation that 0 equals the square root 3x minus 5. Square both sides. Okay, so 3x minus 5 equals 0. Add 5, divide by 3. So x equals 5 over 3, which is actually halfway between the two, but we have to show it. Now we can find this curved area by integrating between the two limits, between 10 over 3 and 5 over 3. And we're integrating the curve, remember, which is 3x minus 5 to the power of a half with respect to x. Okay, go up here with the working out, because there might be quite a bit. So we integrate this using integration by recognition. So I'm going to show you this at the top of the screen up here. And that was root 5. So what we do is we think, okay, something to the power of a half, we're trying to integrate. So if we can think of something that differentiates to get it, then what we can do is we can work backwards. So I'll show you what I mean here. We think of a guess. Now a guess is just going to be the thing in brackets to the power of, well, we're going to be taking away when we differentiate, so power 3 over 2. When we differentiate that, we're going to get 3 over 2, 3x minus 5 to the half. So the bit that we've got that we required is here, okay? But we're also going to have, because of the chain rule, times by 3. So it's going to be, sorry about that, it's going to be 9 over 2 here. It's going to be, change that to 9. Okay. Now, if you don't want that 9 over 2, what you're going to have to do is multiply by 2 over 9 at the top. So when you differentiate, you get that. Okay? That means that when you integrate, this is just going to be 1. When you integrate this, you get that. So that's how you use integration by recognition. Okay? So the answer is 2 over 9. 2 over 9 can actually, because it's a constant, go at the front. Can wait outside for us. 2 over 9, 3x minus 5 to 3 over 2. Okay, and it's going to be between 10 over 3 and 5 over 3. Okay, we do want exact form, so we're going to be having to keep as fractions. 2 over 9. For the first limit, we're going to get 10 over 3 times 3, 10 minus 5 to 3 over 2. And for the second limit, we're going to get 5 over 3 times 3, 5 minus 5 to 3 over 2. So the second term is going to go to 0. And we're just going to have 2 over 9, I'll put this in my calculator now, 2 over 9 times by 5 to the power of 3 over 2. Okay, now my calculator is given that as a decimal, so what I'm going to have to do is do it in third form. Okay, so it's going to be 2 over 9 times by 5 cubed and the square root of that using core 1 power laws. Now 5 cubed is 125, so it's going to be 2 over 9 square root 125. Using our third laws, 2 over 9, going to split it up into root 3, root 25. Root 25 is 5, root 3, so 10 over 9 root 3. Now, a final part of the question is to figure out the total area. Okay, so just giving it a little bit of space to do it here. So total area, shaded. We're going to do a triangle. We're going to take away, not very good at drawing the curved things here, the curved thing, so we get 10 over 6 root 5 minus 10 over 9 root 3. Okay, square units. So that is our final answer. That is a difficult question. Hopefully you followed what was going on there, but there's a lot of things that you need to notice. Probably the most important thing is about that with the gradient and how to put it in y equals mx plus c form. Right, moving on. Question 7. Okay, so for question 7, we've got some functions. We've got f of x, g of x, and h of x. I think I'm going to color code this for you so you can see what's going on. F of x, g of x, h of x. Now h of x we get by doing, we say that for this, g of x, which means you put your answer for g of x into g of x. Okay? Solve the equation g of x plus 2 equals f of minus 12. Okay? So g of x plus 2 means instead of x, you're putting in x plus 2. So instead of x, x plus 2. And that equals the modulus of minus 12. Modulus means you take the positive version of it. So we're just going to have that as 12. Okay, and we can expand these brackets. 3x plus 6 plus 5 equals 12. We know what 6 plus 5 is. That is 11. Okay, take away 11, divide by 3. X is a third. First one done. Find h to minus 1 of x, which is the inverse of h. Before we can find the inverse of h, we want to know what h is. Okay. Now, you should really write this as g of x, but you know maths likes to make things a bit more condensed when we write it, so that's why we just put g of x. Okay. So we're getting our answer for g of x and putting it inside g of x. Okay, so we're doing g of 3x plus 5. So where we've got x here, we're putting in 3x plus 5. So it's 3x plus 5 plus 5. When we expand that out, we're going to get 9x plus 15 plus 5. So 9x plus 20. And that is your expression for h of x, or we call it y. Okay, now when you find the inverse, I have done a video of this to do with trig. It's the same principle. What we're going to do, we're going to be starting with y equals x. We're taking the inverse, starting with y equals f of x, sorry. We're taking the inverse, so we're going to get the inverse of y. When you inverse the function, you undo it, so that's x. So what we're going to do, you don't need to write that extra step, it's just showing what's going on. we basically rearrange to make y the subject, so we take away 20, divide by, to make x the subject, take away 20, divide by 9. And now, because of this principle, we can actually just swap x and y. But all you need to do in your exam is remember to do that. So swap around x and y. Okay, so that's your answer. Part 3, determine the values of x for which x plus f of x equals 0. F of x is the modulus of x, so when does x plus mod x equal 0? AKA, when does the modulus of x equal minus x? Remember what modulus does. Whatever you've got, you make it positive. So you know the answer for your modulus answer has to be a positive number. Therefore, you want this to be obviously positive as well. The only way to make that positive is if x is negative. Okay, but you won't just write x as negative in your exam. You would have to write that x is less than 0. But can x be 0 as well? Modulus of 0 equals 0. So less than or equal to 0 is your answer there. If we read the question, it's a very wordy question, and it's about exponentials, substances, things changing. So, an experiment involves two substances, substance 1 and substance 2. Their masses are changing. The mass m1 of substance 1 at time t hours is given by m1 equals 400 e to minus 0.14 t. The mass m2 of substance 2 is increasing exponentially, and it's shown in the table how that's happening. At a critical stage in the experiment, at t hours, it's a key word here, t hours, the masses of the two substances are the same, are equal. So let's go back, looking at our keywords again. This is M1 and this is M2. So, looking at our question, find the rate at which a mass of substance 1 is decreasing when t equals 10. Give your answer in grams per hour, correct to two significant figures. So, this is a case of using the formula that we're given for substance 1, finding the rate of change. When we're talking about rate of change, we're talking about differentiating. So the rate of change of substance 1 with respect to time, we're going to get by differentiating 400e to minus 0.014t. Now, when you differentiate an exponential, you get the same thing again. You get e to minus 0.14t. However, we have to use the chain rule, and we have to times by the differential of the function inside, aka this function in the power. So we do 400 times by minus 0.014, and we get minus 28 over 5. Minus 28 over 5. Now it wants to know when t equals 10. So when t is 10, we're going to put the number 10 into this expression. So on your calculator, you can type in minus 28 over 5 times by e to the power of minus 0.014 times 10. So that is minus 4.9 grams per hour. Show that t is the root of an equation of the form e to the kt equals c, where the values of the constants k and c are to be stated. That means that we need an expression for m2. We've got an expression for m1. If we get an expression for m2 as well and set them equal, that will show us the values of constants at that special time t. So what we're going to do is we're going to think if this substance 2 is increasing exponentially, it too is going to have e to something power of t. So this is the basics of what exponential growth means. It has something to do with the exponential, increasing it, and your value t is in the power of e. Okay, it doesn't actually have to be e, but there you go. Now we're forgetting that we could have something multiplied in front of the e, and we could have something multiplied in front of t. So we need to put those constants in just in case they're not 1, which they probably won't be. Now this is called your initial condition here, that t equals 0 when the mass of a substance is 75. So M2 is 75 when a e to the b times 0, which is 0, e to the 0 is 1, so a is 75. So we figured out that value rather quickly. Now, when t equals 10 hours, the mass M2 of the substance is 120. So we sub in 120 for M2, and we sub in 10 for t. Now we want to solve this to find the value of the unknown b. So we divide by 75 on both sides to get the answer of 8 over 5. And we now take ln of both sides. Ln of 8 over 5 is 0.47, etc. And then we want to divide by 10 to get that b equals 0.047. That completes our working out for the equation of the substance M2 by putting 0.047 here. So, moving on with the question, at this special time t, put these two equations together, so 400e to the minus 0.014, and this time big T, because they're the same at this instant, equals 75e to the 0.047 big T. We want it in the form asked for in the question, where we've just got an exponential with a number times t, and the power equals another constant. So we want to divide by 75 on both sides of the equation, and we want to times up by this, e to the 0.014t. Okay, the reciprocal of that if you want to be precise. So 400 over 75 equals, using your power laws, e, add the powers when you times, e to the 0.061t. So to give this expression, we just do 400 divided by 75 on our calculator, and we get the answer that e to the 0.061t equals 16 over 3, aka k equals 0.061 and c equals 16 over 3. They're the unknown constants from the question. Final part, trying to solve this equation, part 3. So, as I was about to say, we take ln of both sides, which is the inverse of exponential, and then we just divide by 0.061. So t equals ln of 16 over 3 all over 0.061. And if you put that on your calculator, you're going to get the answer that t equals 27.4 hours to 3 significant figures. Question 9. So we've got a very long question here, and you're going to need your green formula book with the trigonometric identities. Right, let's get on with it anyway. Part I. Prove that sine, I'm not going to write all that out again, theta minus alpha, you can see the bits that you're going to be using the formula for. Here, 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 here. Okay, we want to prove it equals tan theta, so we have to start with the left-hand side and get to tan theta. Okay, so starting with the formula sine a plus b. I'm going to put in green when I've used the green formula book. Okay, so A is theta and B is alpha, and it's a takeaway version. So I'm looking in my book at sine A minus B for the first one. And we get sine theta cos alpha. Because it's minus, it's a minus here. Cos theta sine alpha. It's the first bit done. Next bit can stay the same. It's already in terms of sine of just a single angle. Now we need the sine of A plus B formula for the second part, which is exactly the same but with a plus in the middle. Sine theta cos alpha plus cos theta sine alpha. That's the top row of your left-hand side done. Same for the lower part. We're going to now use the formula cos A minus B for the first bit. Okay, so from your formula book, it's going to be cos theta cos alpha. Because it's a minus, it actually goes to plus here. Sine theta sine alpha. We've already got plus 3 cos theta, and then use your formula book again, but this time with a plus, which will give you the same thing but with a minus in the middle. Cos theta cos alpha minus sine theta sine alpha. So now we have to try and simplify this. Can you see that on the top row you've got sine theta cos alpha here and here? Okay, and you've got a minus cos theta sine alpha and a plus cos theta sine alpha there, so they cancel. Here you're going to have sine theta sine alpha minus sine theta sine alpha, so they cancel, and you've got this one repeated here. Okay, so that means that when we simplify, we get on the top 2 sine theta cos alpha add 3 sine theta, and on the bottom we get 2 cos theta cos alpha plus 3 cos theta. Okay, now what you want to do is you want to factorize. Okay, you cannot try and fudge it here by doing stuff like dividing there, because that's cheating. It's the whole thing here divided by the whole thing here. So to simplify, we first need to factorize. So on the top we can factorize out sine x, sine theta, okay, which gives us in the bracket 2 cos alpha plus 3. And on the denominator we need to factorize. We can factorize out not cos alpha, cos theta. Okay, so factorize out cos theta, and you get on the bottom 2 cos alpha plus 3. Does that look familiar? Yes, it does, because you can now cancel, because this is all multiply and divide here, so that's okay. So you're left with sine theta over cos theta, which equals tan theta, and you've proved it for 5 marks. Okay, now we have to use this formula to do something maybe constructive. Okay, so let me just erase what I've just done. We've shown it, it was given in the question. Even if you couldn't do that proof, you would still be able to do part 2, which is a good thing about this question. So we need to see how we can use part 1 to solve part 2. Okay, and we want the exact value, so you probably can't just put it in your calculator like that, because the calculator will start rounding for you. So what we need to think about is, how does this relate to this? How do they look similar? Okay, and if you have a think, if you say that theta is 150, and we can see that because here it's like spot the difference, theta 150 degrees, and we need to have a takeaway angle here to get 149 and plus an angle here to get 151. So that means your other angle alpha is 1 degree. So we have just talked about the fact that this all simplifies to tan of your angle theta. Okay, so that whole complicated looking thing, apart from the fact that there's 4 over 3 and 12/9, stuff like that, which we'll talk about now. So we can actually take out 4 from the top, 3 from the bottom, and then we get exactly the same as above in terms of the coefficient numbers. So we get sine of 150 minus 1, these are in degrees by the way, plus 3 sine 150 plus sine 150 plus 1, and that's all over cos of 150 minus 1 plus 3, remember we factorised out cos 150 plus 3 cos 150 plus 1. We've just shown above that that's going to be tan of this thing. So this thing in the big brackets is just a fancy way of writing, I don't know why you would want to do it, tan of 150 degrees. Okay, so let's try tan of 150 in our calculator. See if it would give us exact form. Yeah, minus root 3 over 3. Which is going to give you minus 4 root 3 over 9 in exact form. Okay, part 2 done. Part 3, final question on the paper. It is given that k is a positive constant. Okay, here, solve for theta between 0 and 60 degrees in terms of k. So we need to play spot the difference again, and we need to think, what is the angle theta? Okay, so the angle theta here, in this case, is 6 theta. But what else have we done? Have we done anything else? Minus 15 degrees is corresponding to the alpha. So alpha equals 15 degrees of 6 theta. Equals k. So when we solve this, we do tan to minus 1, we get 6 theta equals tan to minus 1 of k. Now let's think about why it's a 4-mark question, not just say a 2-mark question. The reason is because you've got the fact that theta is between 0 and 60 degrees. And you've just found a solution for 6 theta. So to extend the range for 6 theta, we're going to times by 6. So 6 theta is between 0 and 360 degrees. Now think about your tan graph. The tan graph, you need to just add on 180 or take away 180 degrees to get the next solution, because that is periodic. Now your calculator, or this, is going to give you the smallest possible angle that works. So to get the next one within the range, what you're going to have to do is you're going to have to add on 180 degrees. Plus 180 degrees. Okay, but their answers for 6 theta, you were asked for theta. So theta equals, divide by 6, 1/6 tan to minus 1 of k, or divide the second equation by 6, theta equals 1/6 tan to minus 1 of k, divide by 6 plus 30 degrees. And that's it. That last question is really testing your understanding of trigonometry, but it's a good question. I hope this video has been useful. If there are any questions that you've got, or if you think I've made maybe a mistake, just let me know and I'll get back to you. Okay, thanks for watching. Good luck in the rest of your revision and your exams, and achieve maths.